Welcome to Snark Chocolate, where we unwrap the bittersweet layers of building zero-knowledge projects. I'm Queenie, and I will be co-hosting this episode with Omer, co-founder at Ingoyama. Today, we're thrilled to be joined by Anurag Arjun, co-founder at Avail, to unveil its ambition to become a unifying force in the roll-up-centric world. Hi, Anurag. It's great to have you on the show.
Yep. Thanks for having me. Very nice to meet you guys and very excited to record this.
Cool. So first of all, would you like to introduce yourself and tell us what are the projects that Avail is building now?
Yeah, so I'll just give a quick intro. So Anurag, co-founder of Avail, previously also founded Polygon, been in the space for about 7 years now. Before that, I spent about 11 years in fintech, regulatory, tech, product and engineering roles. Did a startup before that as well, which didn't quite work out, but essentially entered the crypto space in 2017 and have built most of the Polygon stack at the time, the POS chain as you see it now, the Plasma solution, a lot of the bridging infra. Also acquired the ZK teams that are, like that I eventually developed things like the ZK EVM, Plonky 2, Plonky 3, Maiden, and so on. And started Avail within Polygon back in 2020. And we spun Avail out of Polygon in March 2023, last year, and we've been running it independently since then. Since then, we've launched on mainnet a few months back. Also raised funds earlier this year from a bunch of great investors like Founders Fund, Dragonfly, Cyber Fund, and so on. And yeah, I mean, essentially, Avail, what we want to build for Avail really is that so blockchains have been undergoing this kind of evolution. They started off as very opinionated, monolithic sort of constructs, and they've evolved into a much more scalable, multi-chain sort of a construct. So Avail, what we really built at Avail is this more opinionated vertical end-to-end stack in terms of having this infra in place so that you don't feel like you're having 100 chains, you're interacting with 100 chains, you just intuitively see them as one single system to interact with. So essentially infrastructure for broadly what is known as the roll-up centric roadmap, but much more.
Yeah, I think many people initially got to know Avail as a DA solution. So I'm curious, how does it differ from like Celestia and the EigenLayer DA, some other DA solutions?
Yeah, I mean, of course, like when we kind of try to approach this with this vision and ambition of creating a much more cohesive multi roll-up sort of infrastructure, we have to start low level, at the low level infrastructure, right? Like you cannot just be building optimizations at the vertical, at the higher app layers. So we started very low down the stack. We sort of starting initially with what the component which is best known from Avail, which is the data availability layer. Uh, it's essentially very similar to what Ethereum wants to do on which is on its long-term danksharding roadmap. So this component is called data availability sampling with validity proofs. So that's something that we've already built and released on production. How it is different from other approaches in general is that I think um, Celestia builds this component out with using optimistic fraud proofs. EigenDA is, I think, more of a committee sort of a construction in general. But yeah, I mean, as you said, right, like that's what it's well known, what is best, Avail is best known for. But really, the intent is much larger in scope. It is to kind of enable app developers to build apps and not think about the 100 different chains, what are the security guarantees, what are the trust assumptions for each chain that they develop on, right? Like it's like basically we the end goal is to enable app developers to build an app once, deploy it somewhere, and then it works seamlessly with the rest of the ecosystem. With users can access it from anywhere, for example, and so on.
I see. So applying zero knowledge technology here is basically um, trying to make the system more trustless.
Yeah, I mean, see, we've gone through the years of blockchain evolution in various parts, right? Like initially, it started off with this concept of crypto economic security. Like, so if you look at the first blockchains, Bitcoin, Ethereum, all the others that have come later, right? Like, so all they kind of started with this assumption that okay, we have these n number of nodes. We will run the same node with n participants. Each of them will re-execute, and then we have various different consensus mechanisms to arrive at like what is the right state, for example. uh, in the recent 3-4 years, what has happened is the zk technology specifically, or validity proof technology, has improved by leaps and bounds. So instead of relying on re-execution by a number of different parties, it all comes down to how can we just mathematically ensure the correctness of these executions rather than having to re-execute them. And so essentially, the idea is that how can we compress this execution into a succinct proof? And if we can do that, why should we have one chain? We can have hundreds and thousands of chains, and all of them can just be verified pretty cheaply, for example. And so that is really the construct that we began with at Polygon when we started working on the first zk rollup. Essentially, we realized that it wouldn't be just one zk EVM that we will come up with. There will be eventually hundreds, even thousands of zk EVM chains, and that has roughly proven to be accurate, right? Like, I mean, there's tons of zk EVM chains, there are tons of zk sync chains, there are tons of Starkware chains coming, and OP, even the optimism stack is going into zk, for example. And so essentially, how can you move your guarantees, almost like most of your guarantees, from being crypto economic secure to cryptographically secure? I think it's just a easier construct to work with to make these systems much more scalable. Like currently in blockchain, we don't even have that much usage, right? Like mainstream, it hasn't reached mainstream yet. We don't have the kind of demand that population scale systems really require. And to get to that, zk, or specifically validity proof technology, is really a must.
Cool. I guess that's also something like people are excited for ZK. But on the other hand, um, as we all know, like ZK is currently still maybe slow and expensive in terms of proof generation. So I'm curious, how does it affect, for example, the efficiency and the cost for like Avail DA compared to other systems without ZK? Do you have any numbers to share with us?
Yeah. See, it's actually, yeah. I mean, see, sometimes when we kind of like think about zk systems, we think about this big monolithic of how can we convert the EVM into zk, for example, right? Like, so zk is much more than that. Like, you can actually take any simple state transition or mathematical function, for example, and encode it into a way that like that can be converted into a proof. And so at the base layer of Avail, which handles the data availability part, right? Like, I mean, essentially, we employ very simple circuits, specifically in technical terms, for like data encoding, ensuring that the data encoding is right. And these are very lightweight circuits, can be generated in milliseconds, maybe seconds, for example, if it's a big block, and can be verified quickly in milliseconds. Like, so there are different kinds of like systems. In general, we use a very lightweight sort of validity proof system, which doesn't have really any overhead.
Uh, Oma, do you have like follow-up questions on Avail DA?
Not sure if about Avail DA, but I want to maybe take a step back and talk about Avail's vision. So, Anurag, you wrote back in February about the unification layer for Web3. And looks like, well, I'm interested to hear more about what you guys have been cooking recently, let's say past 6 months, because I see you have like interesting components, Nexus, Fusion. How does it all fit into this like unification layer?
Yeah. So in general, see, like again, like maybe I'll just start with some context, right? Like so, essentially, like Ethereum when it started in 2014, it began with this notion that like we'll do this blockchain. It'll have a lot of nodes. Everyone will re-execute, for example. Around 2020, the thinking moved to can we how can we make this more scalable but not on the same chain, right? Like so there is two different schools of thought, right? Like there's the more Solana school of thought, for example, or the Aptos or the Sui school of thought, where like let's just make a faster blockchain, a bigger blockchain, more parallel blockchain, for example, right? Like and the thinking in Ethereum land was, can we kind of scale this like a different way? Can we add more layers? Can we add more chains, for example? And it's kind of similar to how like apps on the internet really work, right? Like if you kind of see how apps on the internet scale, we don't have apps on the internet live on one single big supercomputer, right? Like they live on different servers, and they scale independently based on demand. And so if you want to get to population scale, you have to really think hard about how this technology will reach population scale, right? Like and so I think the roll-up centric roadmap, or it's essentially 1,000 chains will have more throughput than one, right? Really, that is really, like if you want to kind of simplify it, right? Like really, that is the question. So now when Ethereum started thinking about this, like we thought that of course this was philosophically the right way to scale. Now, but what will be the infrastructure that will be required to kind of reach this, right? Like it's not sufficient to just have enough capacity for data availability on the base layer to support, let's say, 1,000 rollups. That's just one part. You also need, like if you kind of look at the Ethereum landscape today, you have hundreds of layer twos or rollups, for example, and liquidity moves from the base layer to these rollups through bridges, for example, through native bridges, for example. All of these ecosystems are different, have different trust assumptions. uh, Incentives for moving from Ethereum to the layer twos are all different, for example. So it's almost like having 5 different players or 100 different players coordinate this roadmap, essentially. There is no built-in interoperability. There is no essentially there's no incentive as well for kind of ensuring all of these tie in together, really. And it actually has a lot of consequences. So something like a protocol, like a successful protocol like Aave, for example, deploys has about 12 deployments across different chains. It's the same code, it's the same setup, but they are present across 12 or maybe more chains. Why is that? Because they don't want to lose out on users on these chains, because users are very hesitant about moving from funds from one chain to the other, for example. And that's why app developers like Aave have to resort to this. It shouldn't be like this. It should be that liquidity should be able to freely flow through this ecosystem. It's not only about liquidity, right? Like it's just about communication. Like message passing should be seamless, essentially. And really, sequencers, like if you look at things like sequencers, for example, right? Like sequencer or operators, in the sense, operators of these rollups are coordinated separately. They have their own incentive mechanisms, coordination mechanisms, and rollups have to, like rollup developers have to invest a lot of time and energy into bootstrapping some of these rollups. I saw this comment on Twitter last week, I think from Andre, who was saying that the cost of spinning up a chain or bootstrapping a chain really is in the range of around 14 to 15 million dollars, which includes, let's say, things like exchange connections, on ramps, off ramps, liquidity, and so on, right? Like, I mean, essentially, bootstrapping in L1 for sure requires that kind of a thing. Bootstrapping in L2 shouldn't require that much, essentially. Uh, I'm also not talking about, like the benefits of an L2, for example. There's no bootstrapping of validator compared to an L1, but I mean, you get the gist, right? Like, so the thing is that if we want to kind of reach this system, uh, which kind of is modular, but it's still very interoperable, and you want to solve actual needs for building all the infrastructure has to have an end, right? Like, it is to empower the developers. It is to empower the app developer to cook, really. And developers in general expect a lot of things to come out of the box. In Web 2, that's really the case, right? Like, most app developers will start with a set of APIs, set of SaaS services that they're already conversant with, will mix and match some of this, bring their business logic into it, and then deliver the product. That equivalent in blockchain land is right now still very much up in the air. You really need very integrated sort of an experience, and so that's why, just spending a lot of time giving context, but that's really where like the Nexus component and Fusion components that we are building come into the picture. So what we are really looking to do is not only provide this DA layer for scaling rollups, we also want these rollups to be coherent, to be talking to each other seamlessly. You don't need to have like an exchange connection from day one, on ramps from day one, for example, incur all that upfront cost. Focus on building your app. You can tap into the liquidity of any other rollup, for example. You can tap into the users of any other rollup, for example. And something like Nexus is crucial there. Nexus really is, about interoperability between rollups. It allows you to kind of app developer on any rollup operating on Avail to kind of access users on other chains, liquidity on other chains, build your app so that you have access to the entire ecosystem, not only that chain. So that really is the end goal of Nexus. Fusion really is this experiment that we have been running, in the sense, as with any other new L1, we have to bootstrap a lot of cryptoeconomic security. And so we thought, of course, we will bootstrap our Avail native token, but why shouldn't we kind of also piggyback on, let's say, existing cryptoeconomic security of Ethereum and of Bitcoin, for example, and so on, to kind of, have this very secure base layer, for example. So these are some of the things that I've been working on.
So yeah, thank you for delivering this background on the context. I think it's really useful to understand better what you guys are building. Maybe take us a bit deeper into the tech stack. Like, what technologies are you guys using? What's the stuff you guys are actually building on the day-to-day now?
Yeah. So with Nexus, we are primarily building this custom coordination runtime. That is primarily we are writing it in succinct SP1. We started with RIS 0. We are kind of in between stacks. So we have prototypes in both ready, but broadly we are using both these stacks at the moment. We will choose one of them to go into production with. So, but that's that is the primary stack we are using for Nexus at the moment. So with Nexus, what we are building is really, you can think of this as a ZK rollup, with which app specific ZK rollup, which does only two things really. It maintains state between all rollups that are coordinating. So we kind of maintain things like state routes, state changes, state diffs, that kind of a thing. And we kind of keep a track of all the intermediate proofs, execution proofs that are coming in. At the base layer, the Avail, we kind of we have actually two networks. We have a validator run data availability base layer. We also have this network of light clients, and so this is a light client data availability sampling light client that we built from scratch, and it works with KZG polynomial commitments, validity proofs, and so on. And that gives ordering. We provide ordering guarantees. So we have ordering guarantees with validity proofs. We kind of take in the execution proofs from these rollups, and then we kind of aggregate them on Nexus. Really. So the stack, broadly, the stack is this. With Fusion, we kind of customize the Avail base layer and integrate it with Symbiotic on the Ethereum side to make use of these restaking assets, for example. Broadly that is the stack.
So I guess that you put emphasis on modularity, or maybe my question here is what's the dev experience? Like, can I just pick parts of this stack and use them in different ways? How am I as a developer supposed to use Avail? What's the different ways to use it?
Yeah. So I mean, it's really in phases. For now, what is live on production? It's mostly something that rollup developers or chain developers really use. So we have adapters for various rollups, including Polygon, Arbitrum, Optimism, zk Sync, Starkware, Stacker, Sovereign, bunch of other rollup stacks as well. So we kind of work with these teams to create these adapters, and so then app developers don't really have to think about how to integrate with Avail. It just comes out of the box in general. From even Fusion is abstracted away from the end user. Like, they don't have to really think about this. They just need to kind of interact with, let's say, some contracts on through which they can stake, for example, or things like that. Nexus, once it kind of releases, that is meant to be like a backend for let's say wallet SDKs, intent SDKs, app dApp development SDKs, where it will not seem very different from how you would access like a chain via an RPC, for example, right? Like, you just kind of go through an SDK and then, let's say, do a cross chain transfer, or something that happens across multiple chains, for example. In general, we may or may not have like a front end that we own in general, but at the moment it's more or less like a developer infrastructure platform. One thing that we certainly want to do on top of this is, like, at some point in time we will also kind of do a more opinionated app specific rollup SDK, which will serve as more like a serverless sort of, like something like an AWS serverless sort of a function, where you kind of just write your business logic, upload it into the cloud, that sort of an offering. That will come at some point in time once these rollup stacks are better. Like, I'm very bullish on something like Stacker, for example, where you can build your rollup using TypeScript, for example, or even Python at some point in time. At some point in time, what we already been working in the background. Right now we are not making it too public at the moment, but we've been also working with a bunch of players on like these open protocols. So right now you see one or two of these protocols, like, let's say, Farcaster is open social or Lens is open social. We've been also working on a more higher level construct with some of our partners, which can do essentially what are blockchains good for, right? Like, blockchains are good for really removing intermediaries, for example, in general, or just enabling coordinations of people, of companies, for example. And so I come from this fintech regtech sort of a background. I used to work on a lot of these open protocol systems, not in Web3 but outside of this, and I've spent a lot of time in things like data sharing, open data sharing protocols, open commerce protocols, and such. And so I think really, like, once we kind of build this foundational architecture, we have to actually go farther up, actually getting into things like how can we coordinate let's say e-commerce for the long tail, for example. In general, how can we coordinate like transportation, how can we coordinate payment protocols, for example. So bunch of those things, like once we are ready, we will kind of release more information. But really, the objective is to kind of start low level, slowly build up to a much higher level of abstraction than we are in currently.
Yeah, thank you, Anurag. I think this full stack strategy is very interesting, but I'm curious, like, which product do you think will be the main driver for developer acquisition, or you think like the more products you provide, like this full stack uh, option will be the main driver?
So see, there are phases to each product or project, right? Like, I mean, essentially, I mean, at the moment, like the initial JTM that we followed was like, so like while Avail can be used for sovereign rollups, like you can actually, like we have few high quality teams that are building high performance sovereign rollups on top of Avail, for example, and so on. But the first GTM that we initially focused on was, like offering this DA service to Ethereum rollups, for example, right? Like so it's phases, right? Like the next phase will be ensuring these rollups can talk to each other, for example, right? Like so, how can we get an Aave to go from 12 chains to one chain, for example, but still retain the same user base, same liquidity, same TVL, for example. So that is the next phase. But in general, like, see, we are still in this, kind of limited constraints or scopes that the blockchain industry has built over the last few years, right? Like, we are still building. If you kind of look at it critically, it's still the same DeFi construct, it's the still same sort of economy. It's not really growing too much, right? Like, I mean, essentially, you need to get more and more of real world economy on chain, really. And so some of that is happening with things like RWA on the financial side. But I think probably a year or so out, we will start getting into much more platform unbundling sort of use cases. Now, what do I mean by that? Is really like, if you kind of look at the most valuable companies in the world. So these are, let's say, Google, Facebook, Amazon, Uber, Airbnb, and so on, right? Like, I mean, if you kind of look at them critically, these are not just production companies, right? Like, these are actually platforms. So if you look at Google, it does offer a search product, but it really is a platform to connect merchants or advertisers with like their consumers, like in general. If you look at Amazon, it is literally connecting buyers and sellers. Airbnb connecting like hosts with customers, for example. Uber, like passengers with drivers. So the like our thesis is that the world is moving from a phase where company, in the past, company used to create a product and the company then used to sell the product to customers, right? Like, I mean, here, if you kind of look at it critically, on Facebook, the creators are the content creators. On Uber, the product is really the rides which, like, the drivers bring it, right? Like, Uber doesn't do that, right? Like, for example, right? Like, I mean, Airbnb doesn't own the properties that it helps rent out, for example, right? Like, so essentially, if you look at that, and if you look at how the stock market is valuing these companies, this is the future which the world is really progressing to. And essentially, the I sincerely believe what really needs to be done is, like, when the internet started, it started with a very open ethos. What has happened in the last few years or last decade or so is that we've kind of turned this into a more closed sort of ecosystem. So, like, Facebook had its API open for a long period of time until like they shut down. There were a lot of valuable companies built on it, like Zynga, for example, and so on. And so now these are these closed ecosystems where only the incumbent generates value. Now, to really like deeply about it, I believe what blockchains are really useful for is this unbundling of these platforms, especially for the long tail of consumers and merchants. Like big brands already have a lot of distribution scale, for example, and then they have access to all the tools that are disposable. There's a long tail of merchants, of customers, of sellers that like these platforms are not able to meet. And so the platform unbundling thesis is something that I'm very bullish on, and that's really, I think, where the world is moving. You need Blockchains are a great tool for connecting peers to other peers. That peers might be people, they might be companies, doesn't matter, right? Like you see, I mean, if you kind of zoom out a little, right? Like the world runs on ledgers, and global commerce, the economy works on how these ledgers are connected to each other. How seamlessly are they talking to each other? Like 20 years ago, it would have been very difficult to kind of order something, like from US, like, and you're sitting in China, for example, right? Like, I mean, and today it is taken for granted that like the purchase will go through the like, so things like that, right? Like, and we have had APIs for a long time, but even then there are so many systems that are siloed, they don't talk to each other. And so the question is not just technical, right? Like it's also incentives, it's also how can you make people coordinate each other, right? Like, I mean, and instead of having one party sign bilateral agreements with other party, like if you want to use an API, you sign a contract with them, for example, right? So instead of doing a one-on-one bilateral agreement, can we have designed these systems where people can plug in and then plug into this composable set of systems, right? Like, I mean, that's really the very high level construct we are kind of trying to build against, really. But we do it slowly, one at a time.
Great. So Avail should make its product as open and flexible as possible.
Yep.
Yeah, cool. And also, I think you mentioned interoperability problem several times just now. So I think it's a very important topic that many people in the community are actually focused on. And it seems that many projects, also including Avail, are currently addressing this issue within their own ecosystem. And Avail is now using ZK to solve the problem. But it seems the inter-ecosystem interoperability issue is still there. So I'm curious, how do you see that we will finally address this problem among other ecosystems? Is ZK will be the end game, and is the maybe probably the biggest ecosystem in the space? They will have more power to set the standard. What do you think?
See, in general, like in blockchain, everything is a very PvP sort of a game, right? Like every project wants to tout that it's the best, and every ecosystem wants to tout it's the best, for example, and people are always fighting with each other. The kind of adoption that we have is very low, right? Like, I mean, it doesn't make sense for these ecosystems to fight each other, right? Like, I mean, I think all of these ecosystems should exist. They should do as much as to drive real world adoption as much possible. And the only way to kind of link all of these together is not to ask them to adhere to a standard, but take what they have and package them in a way that can be composed with each other, right? Like, and by far, I think, I mean, of course, there are a lot of other techniques also possible, but by far, my thinking is that GK is very with a very powerful tool to kind of make this possible, right? Like, I'll give you an example, right? Like, so right now, like even within Ethereum L2s, for example, like there is the Optimism super chain, there is Arbitrum Orbit chain, there is zk Sync Elastic chain, Polygon Aglair, Starkware, like, so all of these all on Ethereum, but having running these separate interop initiatives, for example. Now, there is a lot of liquidity on the Ethereum base layer as well. A lot of liquidity on Solana, for example. A lot on other chains, for example. Right? Like, I mean, why should there be these pockets of fragmentation essentially? And so, I think. So there has been tremendous progress with what we can do with ZK specifically. So with Succinct, for example, we've been kind of building out these consensus verifiers. So we built one out for our the consensus mechanism that we built. We have on our chain, which is Grandpa Babe. There is a Tendermint verifier, for example. There is Ethereum consensus verifier, for example. So all of this is ultimately going to be this aggregation of consensus verifiers, execution verifiers, data availability sampling, validity proofs, for example. And because all of them are ZK based, there exists a way to kind of compose them with each other. Of course, I'm not saying it's trivial, because some of these systems use different proving systems, for example, and so on. But one interesting thing that we have been working on is, like, we took on this challenge of composing a ZK Polygon ZK EVM proof with a ZK sync execution proof, and we have been able to kind of do that. It's not very performant at the moment, but we will optimize it as we go forward, for example. And so this approach does not really, like, didn't require the active intervention of Polygon or ZK sync, right? Like, we did it on our own, for example. And so that, I think, the permissionless nature of taking what these different ecosystems have and then converting into this standard, like, it's not like a standard that everyone should agree on. It's just that it's just a common basis on which we all can agree.
So we mentioned ZK a few times in this conversation so far, right? So we have elements from zero knowledge in the data availability layer. There is also, you mentioned that Nexus, I believe, like doing some kind of like ZK aggregation. I'm trying now to package everything, kind of like to get your take on or Avail approach to zero knowledge proofs more broadly. Kind of like, what are you guys building in house? What would you like to promote for other engineers to build? Which other projects you guys are working with now or in the past or future? How does it fit into kind of like the ecosystem that you guys are basically trying to build?
Yeah. So if you kind of take a step back, right? Like, I mean, essentially, like, if you look at Ethereum, right? Like, the Ethereum's architecture is that there are two chains that Ethereum runs. There is a beacon chain, which does handle the data availability part. Then there is the actual execution chain, which was the original chain that runs smart contracts. And typically you have like rollups on top. Typically the execution execution chain for Ethereum ideally should just be used for rollup verification and so on. Of course, it's a general purpose EVM execution engine, so it gets used for variety of different things as well. So if you now compare it to Avail, like, so the base layer Avail DA is really functionally equivalent to what the beacon chain in Ethereum does, right? Like, handles the data availability part of the chain. Nexus is really our execution engine. It's not an EVM smart contract platform. It's a very light runtime that does only a few things, but it does it really well, very performant. It's essentially a proof verification runtime, really, and you can actually verify various different ZK proofs on it. One thing that we kind of verify in it is the aggregated interoperability proof from various chains through which, like, people can coordinate. But essentially this is a proof verification component. Now, we've been working with a variety of teams. We work with Succinct, we work with Risk0 to build some of this out. We work with Symbiotic on the more fusion side. We work with like a variety of other ecosystem projects on things like fast interop, fast finality, for example, and so on. We work with a variety of roll-up stacks in general. In general, the opportunity for various projects and builders is to kind of, let's say, there's a lot of opportunity building out, uh, like proof verifiers on Nexus for different roll-up stacks, for example. There is an opportunity for more app-specific roll-up stacks, specifically on the ZK side. Let's think taking succinct SP1 and putting a roll-up stack on top of it, for example, which uses succinct SP1 as the prover, for example. Taking RISC0 as the prover and putting up a roll-up stack. Taking Stacker, which allows you to write TypeScript apps, for example, and convert it into more ZK verifiability, for example. Utilizing Symbiotics infra to build a more decentralized roll-up as a service provider. Right? Like today, roll-ups have to kind of contract with a RAS provider and spend a lot of effort in kind of bootstrapping a roll-up. Can we kind of do a much more automated setup, for example? Bunch of things like that, right? Wallet intent SDKs, wallet SDKs, wallet cross-chain wallets. So bunch of these things, we have a lot of people already in the ecosystem, but there's a whole lot of opportunity that can be there to kind of create this more cohesive stack.
I think it's fascinating how you guys manage to tie together probably 95% of projects in the Web3 space. Thinking from my point of view, just by talking with you now, I can think about like 4 or 5 different ways in which we can kind of like fit into the narrative. Before we go, I really want to squeeze like one quick question. I've been following your work and obviously a big fan for many years. And I was wondering what would you consider as a success? Like when would you say, when would be the time for you to say, yeah, I'm done. That's how it's supposed to be.
Yeah, see, how I think about this is essentially, even before getting into crypto, I was always into these problems of, like how can we more efficiently coordinate, right? Like essentially at those times it used to be, I used to look at from the lens of fintech, right? I'm still a very big fintech buff. I spend a lot of time in those circles in general, but really the idea is that the entire economy, if you kind of look at the last tens of years or maybe 100 years, for example, the technology has really enhanced trust between people on this planet, really. Like if you look a few 100 years ago, people used to live in small communities and had this very small circle of trust, right? I call it this circle of trust within these communities, and you never used to trust strangers that much. Things have progressed so much, especially with technology becoming so prevalent, the internet, for example, and so on. Like more people are talking to more people are connected to more people than ever before, right? And you have completely new ways of working, like something like influencer economy was not a thing maybe 10-20 years ago, right? Companies used to do print ads, TV ads, that sort of a thing to like market and sell to customers. Today people trust their friends who are talking about a brand, or let's say influencers who kind of like talk about a brand, for example. So you trust going to Google and doing a search, for example, and you trust reviews on Amazon, for example, or like basically the lens that we view trust with has changed a lot. But still you really require this more trusted mechanisms, right? Because I think really the business opportunity and the philosophical opportunity for me personally is really how can we make more and more people coordinate with each other, right? Even today, like the world is broken down into high trust societies and low trust societies. Like most developed countries, like people in developed countries don't really understand this problem that much, but really there's much more that you can do in a high trust society that you can do in a low trust society. Like it's just much easier to start a business, to do, like job, take risks, for example, and so on. And the internet and all of that has brought that, like it has made things easier. But still, I think we want to make it more easier, right? Like for example, in general, how can we allow direct peer-to-peer sort of commerce or economic transactions, right? Social and economic transactions. That is something that is very dear to me. Like essentially, um, I want to reach a position where kind of uh, the work that I've done has reached the potential where let's say 8 billion people of us, or even of maybe a half of that, for example, are kind of using this to coordinate really. um, that's really the end goal. Like I mean, yeah, I can get into a lot of that, but yeah, that's that certainly. I like my work, right? Like I think I have not even thought about retiring one bit. So I would like to work till the last days of my life in general, and I would like to kind of that this is really the goal.
That's awesome. Inspirational as always. And yeah, of course, like we want you to keep walking. Just, I guess maybe at some point you'll need to move to VR because you've solved everything there is to solve with Web3 coordination. So yeah, I mean, I guess it's a good time to say goodbye. Before that, we have one last question we ask all of our guests, and this is to name a project you are bullish about.
I think essentially few projects that I'm particularly bullish about, but I talk about like Stacker all the time. Stacker is pretty underrated, under the radar. It's actually given the context of the industry, it's a very great way to get more and more developers onto the technology that we are really building. Succinct is another company that we like, or project that we like very much, really. So they do a lot of cool stuff and pretty efficiently, pretty fast. And I think if they play their cards well, either Risk Zero and Succinct both, right? Like really. Because ZK is not really just blockchains. ZK is like any statement that can be mathematically verified really. And like ZK is going to make its way into how the internet works, I would say much faster than blockchains will, for example, right? Like so I think so those two companies really are building something pretty significant, for example. So yeah.
Okay, cool. Thank you, Anurag. Thanks for joining us today. I think it's been a pleasure. So hopefully we can have you on the show again, maybe in next quarter or early next year.
Yeah. No. Thanks for having me as well, and it was fun having this discussion with you guys.
Thank you.